All right, so now that we've got a basic idea of what the standard sine and cosine graphs look like, let's look at a couple more transformations. Primarily our translations left and right. Okay, so as with all transformations, if we have some sort of a shift of the quadratic and our translation is within the bracket, we head in the opposite direction. So an x minus 1 all squared will take me to the right 1 unit, and obviously a value outside of the function will shift me up 1 unit. So for our trig functions, again, the importance, sine of t minus pi on 4, or whatever the angle happens to be. So we can see a little bit of a typo there. They probably should be f of t's. It's going to shift our graph pi on 4 units to the right and t plus pi on 4 units to the left. One thing that, again, that really is important to note, that the coefficient of our variable or our angle needs to be 1. So sine of 2t plus pi on 4, you would look at that and possibly think, maybe it's shifting pi on 4 units to the left. Let's take that 2 out the front as a factor, get the coefficient of t in this case to be 1. And that would leave me with a pi on 8 inside the bracket. And the actual true translation is pi on 8 units to the left. Okay, so really important that our coefficient of the angle is positive 1. All right, so let's have a bit of a look. So again, first thing I'm going to do is just rewrite the graph as sine of, take the 2 out the front, and we get theta minus 90 degrees. Okay, so we can see it's actually a shift of 90 degrees to the right. All right, so if we just sketch out our standard graph, okay, except we'll take into account, I think, the period, 2 pi on 2, which is equal to pi. Amplitude hasn't been affected, so it's still 1. So my standard graph, where's my 1, is there. So period of pi, so it repeats itself every 180 degrees. So there's 180 degrees. There's my halfway mark. So halfway mark again is there. So that's bad. Again, it's every 180 degrees. Mark the key points. So that's my standard graph. So I think y equals sine 2 theta. Okay. Now, so maybe we might do that in a lighter color. Now we want to shift everything 90 degrees to the right. So let's put across where every value goes. So 90 degrees across, point there. So the axis intercepts don't change. Just where our maximums occur is going to change. So there's a graph, and we have to extend it back. So my green line is the line that we want to identify. Two theta minus 180. Okay, so I think when we're talking about vertical or horizontal translations, I think we need to do it in probably multi-steps. So let's get the amplitude and the period right initially, and then apply any translations that exist. So we go to another one here. All right, again, so in this case, we already have the 2 at the front. The coefficient of t in this case is +1. Pi on 6. So we're going to shift back pi on 6 units. So again, let's just do a quick period and amplitude check. Period is equal to 2 pi on 2, which is equal to pi. Don't forget, there's the n value. Amplitude is again 1. So let's do one cycle of my cosine graph. So period is pi, which is way up here. We've really stepped this one out, haven't we? So there's my sort of key halfway marks. About there. So perhaps we probably should get those values correct to start with. So let's just solve if y is equal to cos 2 theta. We want to solve that equal to 0. Well, where does cosine equal to 0? That means 2 theta is equal to, it has to be pi on 2 or 3 pi on 2 and negative pi on 2. So theta is equal to pi on 4, 3 pi on 4 and negative pi on 4. So they should be my axis intercepts. So where is pi on 4? There's pi on 6 and pi on 3 labelled. So let's make them 12. So pi on 6 is 2 on 12. Pi on 3 is 4 on 12. Pi on 4 is 3 on 12. So it's halfway between, isn't it? Pi on 6 and pi on 3. So we've got that right. Just find a bit hard to read. So my other intercept will be about there, if you like. Again, if that's pi on 4, negative 3 pi on 4 would be 1, and then at what are our intercepts? We also subtract the period, so we're going to have another intercept at negative pi on 4, which might be, where did we say pi on 4 was? About here. So my graph, let's just go there. So my graph over the full domain, well, like, is there, okay? So we've sketched that obviously further than what we need to, and now we need to shift everything. So that's where our intercepts at, pi on 4, 3 pi on 4. Let's get a different color, or you might do that in a light pencil. And we want to shift our graph pi on 6 units to the left. So that means that point there goes to negative pi on 6, which is there. Okay, so this intercept at pi on 4. So we have pi on 4, which we'll call it 3 pi on 12, minus pi on 6, which is 2 pi on 12, is equal to pi on 12. So it's just a small positive, so pi on 12. We'll bring it back there a little bit. This point here, it's got to go back again, pi on 6 units, so pi on 2 minus pi on 6. So that's 3 on 6 minus 1 on 6, which is 2 on 6. And that actually helps us quite a bit, doesn't it? So we can see there that the distance we're moving relative to the axis is one full grid. And I should have tweaked that from the first one. So this axis intercept is going to be in the middle. This one here is going to be in the middle. That point there is going to be back one full grid. So let's sketch our graph. So we're going to go down, nice long sweeping curve. So roughly that's where I'm looking at. Let's just check. We've got to stop at 2 pi on 3. So let's stop my graph at 2 pi on 3. And from negative pi on 6, so that looks okay. Let's label some key points. So we just work this one out here to be pi on 12. And our other intercept was 3 pi on 4 minus pi on 6. So it's 9 on 12 minus 2 on 12, which is 7 on 12. We can label the maximum there, negative 1. Maximum over here, negative pi on 6, positive 1. And I reckon that seems to be pretty much the key bits of information. So again, sort of do it in 2 steps. Okay, do your standard graph where you take into account your period and amplitude. You probably should identify, we should always identify endpoints. So my endpoint, which is at 2 pi on 3, so what is at 2 pi on 3, y equals cos of 2 times 2 pi on 3, so we'll call it 4 on 6 plus pi on 6. So y is equal to cosine of 2 times 5 pi on 6 times 2, which is 10 on 6, which is 5 pi on 3. And so we'll write that as 5 pi on 6, which is equal to cos of 5 pi on 3. So my main angle is pi on 3. Cos of pi on 3 is a half. And in the where's 5 pi on 3? 5 pi on 3 is 6 pi on 3 minus pi on 3, so it's in the 4th quadrant, so we're looking at positive a half, which seems about right. So we're going to call that the point 2 pi on 3, positive a half. Okay, so endpoints are labelled, intercepts are labelled. I've got maximum and minimum labelled. All right. So there can be a bit there in our trig functions. All right, let's look at this next question here. Write down the period and amplitude. Looks like a busy sort of question, doesn't it? Period and the amplitude. So again, the period is equal to 2 pi on n, which is 2. And the amplitude is equal to 5. Right, sketch the graph of the function on the axis below. Label the x-intercepts with their coordinates. Label the endpoints of the graph with their coordinates. All right, so again, I'm going to do a basic graph sketch. We can see that we're going to have to shift everything pi on 3 units to the left. So we're going to sketch a basic trig function. The period is pi. So let's try and get, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1, 2, 3, 4, 5, 6. There's my halfway mark there. Pi on 2, halfway mark, halfway mark. So every 3, 1, 2, 3, All right. 6, negative pi on 2. So every halfway mark are the key values. So 5 is my maximum. My halfway at negative 5. Back up to positive 5. Halfway. So again, let's just do our I took a bit steeper, so not my best curve. Don't like that. Oh, it's too wide. Probably being a little bit pedantic, but still. Oh, it's in the wrong spot. That's why. All right, so there's my, let's label it. That's my y equals 5 cos 2x. And now we're shifting everything, okay? Pi on 3 to the left. So if we're shifting everything pi on 3 to the left, so I've got 12 little grids, haven't I? So pi on 3 is equal to 4 pi on 12. So 4 squares to the left. So let's just do a quick check. 1, 2, 3, 4. I'm thinking it should be there. Okay, and that'll be the point negative pi on 3. 1, 2, 3, 4. 1, 2, 3, 4 would be there. Axis intercept, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So our graph sort of would typically be extended. So my intercept here, if we're extending out, so don't forget, my intercept there is at pi on 4, plus another period, which is 5 pi on 4. Yeah, so 5 pi on 4 minus pi on 3. So we've got 15 on 4 minus 4 on 4 is 11 pi on 4. So it's just a fraction outside of that's not right. Sorry. 11 pi on 12. 15 on 12 minus 4 on 12 is 11 on 12. So it's just a fraction inside my pi value. So that's a bit of a graph. Let's see if we can get a nice flowing curve happening. So I'm going to do it over the whole way and then reduce it to the, like that. I probably should find an intercept first before I sketch that, to say rubbing it out. But I'm hoping you can see that I think it's easiest. And again, we should find that endpoint, work out the coordinate of that endpoint a little bit better. All right, so let's work out a few intercepts. So clearly labeled. So 1, 2, 3, 4. So I guess as a endpoint, I stop at pi. Oh. Stopping there at pi. Don't like the look of that. Let's just check some values, shall we? So let's substitute positive pi into the equation. So I get 5 cos 2 pi plus pi on 3. So pi plus pi on 3 puts me in the third quadrant. So that's the same as 5 cos of 2 pi plus pi on 3. Let's stop and go. Pi plus pi on 3 is 4 on 3 times 2 is 8 on 3. 8 on 3 is 6 pi, or 9 pi if you like, less 1. So that's the same as, so let's go 8 pi on 3. So that's the same as 9 pi minus pi. So that's the same as 5 cos pi on 3. And cos of pi on 3 is a half. So 5 times a half is negative 2.5. Sorry, is 2.5. In the second quadrant, it's negative. So maybe that, let's have a look at this curve. So that should be at 2.5, which looks about right as an intercept. What happens if I make that a negative pi? If I want to check out the end point at negative pi, if that's at negative pi, that just becomes negative pi plus pi on 3, which is negative 2 pi on 3 times 2, negative 4 pi on 3. Cos of negative 4 pi on 3 is negative 3 pi on 3 minus another. So it's in the same spot, and in fact, it's the same angle. So in fact, it's the same value. And the same thing goes for positive pi on 3. At positive pi on 3, if I put positive pi on 3 in there, I get 4 pi on, in fact, I've already done positive pi on 3. So if that's at 2.5, I was looking at 0 actually. Let's put x equal to 0 in there. If I put x equal to 0, I get cos of 2 pi on 3, which is pi minus pi on 3, which again gives me that positive 2.5. So that is the nice thing about our symmetry. Our graph, every period, which in this case, every pi unit is going to be at the same point. So all of these endpoints, negative pi, negative 2.5, that's at the point 0, negative 2.5, and that's at the point pi, negative 2.5. So we've got the endpoints labeled. We want intercepts labeled, so that's just what we have. So we had our, we can confirm it. Our original intercepts were pi on 4 and 3 pi on 4. We wanted to subtract pi on 3, and we worked them out to be 3 on 12 minus 4 on 12, which is minus pi on 12. And then we also said that was 9 on 12 minus 4 on 12 is 5 pi on 12. And then from there, we can just add and subtract our period. So we're going to add 12 on 12, aren't we? So negative pi on 12 plus 12 on 12 is 11 pi on 12, which we'd worked out a bit earlier. 5 pi on 12 minus 12 on 12 is negative 7 pi on 12. Oh, we should put a coordinate. Let's put coordinates, which can be a little bit messy. So negative pi on 12, 0. Negative 7 pi on 12, 0. So endpoints are labelled, intercepts are labelled. Let's read the question again. Sketch the graph of the function on the axis below. Label the axis intercepts, yes. With their coordinates, yes. Label the endpoints of the graph with their coordinates, yes. So, job done. Okay, so multi-steps. And look, absolutely, if we then throw in a little +1 or something like that, you would then sketch a third graph, I think. I think it's much easier to sketch it in stages. All right.